coordinates, and you have a line segment that goes in between them. You know, you can continue it on in both directions. How would you describe the slope of this line in English? Is it increasing or decreasing?
It's increasing, I'm sorry.
Which one?
It's increasing.
It's increasing. Is it increasing really quickly? Like if this was stock prices, would you buy this? No, it's kind of slow. So it's a slow increase. So if I want to associate a slope to this, I would want it to be a relatively small number. Positive because it's increasing, but a relatively small number. Now, with coordinate geometry, everything always moves left to right and up and down. It's the only two directions you get. You're going to get so used to right triangles and coordinate geometry, it's ridiculous. It's everywhere. Here, trigonometry, it just keeps cropping up and over again. If we called this coordinate x1, y1, and this point up here x2, y2, and we want to describe this motion left and right and up and down, the first thing that I'd like to know is how far did I travel horizontally? So how do you find the distance on the x-axis between x1 and x2? You subtract them. Generally, order for slope doesn't matter, but we'll do it properly and go x2 minus x1. x2 minus x1. Now, if I was only interested in the distance, I'd absolute value it, but I'm not worried about distance. I'm just talking about a trek. By the way, if I go that direction, if I go this way 2, and I go that way 2, what's the difference between them? 0. In other words, this is a positive 2, this would be negative 2. So direction sometimes deals with sign, so we have to worry about that. I don't like writing x2 minus x1. I can't stand it. It's too long. I'm lazy. I like to write it in shorthand notation. So the shorthand notation for x2 minus x1 is delta x, also known as change in. When you see delta, it means change. That's the Greek letter delta. All right, so this one up here, take a guess what it's called.
Delta y.
Delta y, and we're going to let it be y2 minus y1, and this is delta y. Slope is a ratio between these two values, the change in y and the change in x. So you have two choices. A ratio can be written in either direction. We just got to choose the one that creates a small positive number. Now, let's see. Would you consider delta x bigger than delta y? Yeah. So let's call this big number over smaller number. And therefore delta y is the small one, and delta x is the bigger one. So out of these two, which one better describes a slow increase? Small over big. And you'll find time over time, if you change the slope of this line to be steeper or negative or really negative, that delta y over delta x always describes the slope of the line perfectly in English. So we're going to define slope to equal change in y over change in x, rise over run, all that other fun stuff. I do not write x2, y2 minus y1 over x2 minus x1 except for one place. I don't like the formula. Plus, I use that to simplify other ugly formulas that are going to come up. So, real quick, let's see how you are with signs. This is usually where you screw up. For example, find slope between negative 3, 5, and 4, negative 7. Lots of different ways of doing this. I highly suggest you write this first. The first common mistake with slope is putting the x's on top and the y's on the bottom, because your brain has been trained to go left to right. When you see change, think of it as you go to a grocery store and you buy a $1 candy bar and you give them $5. They give you $4 back, and that's called change, and it's 5 minus 1. So when you say change, it means subtract. So you're going to subtract the y's over the subtraction of the x's. Keep the order the same. I could care less if you go 1 to 2 or 2 to 1. It really doesn't matter. So tell me which way to go. 5 minus -7. Highly suggest after a minus sign, the first thing you put is a parentheses, otherwise you'll screw up signs. Over.
-3 minus 5.
So this becomes
12 and -7.
12 over -7, also known as -12/7. Now when we talk about the slope rise run language, if you start at a point, let's say we start at, it really doesn't matter, start at -3,5, where would I go from this point to deal with -12/7?
Because it's you would go
You go
decrease
down 12.
So you go down 12
And over 7.
and to the positive side 7, and you generally get a line that looks like this. And that would be the slope of the line, -12/7.
That's a steep line.
It's a very steep line. How about between these 2 points? What will be the slope between those 2 points? I'll let you do it. And the slope is?
0.
0. What does it mean?
It's going in a straight line. It's a horizontal line.
All lines are straight.
You know what I mean?
So it's a horizontal line. It goes through 5, 3, and -2, 3. The slope on this thing is 0. I'm going to word it out because if I write 0, it gets lost in the maze. Do not call this no slope. That is totally different. This slope is 0 or horizontal lines are associated with it. All right, what about 4, -3, and 4, 5? 4, -3, and 4, 5. This one is undefined. The slope, the line that is associated with it is vertical. So this is slope equals undefined. The book will call it no slope. I highly suggest you do not call it no slope because people take no slope and they associate it with 0. I'd rather you say undefined. And it's associated with vertical lines. Where this one is horizontal. These 2 things also lead into the equations of these 2 lines. For instance, the equation of this line, what's the only thing that's remaining constant? Is the y coordinate, which is 3. The equation of this line is literally y equals 3. If I say graph y equals 3, that's what it looks like. It's a horizontal line that goes through 0, 3. All right, the equation of this line then,
X equals 4.
x equals positive 4, because x is always equal to 4 no matter what y is equal to. Those are probably the 2 hardest things I can ever ask you on a test. It's weird. I'll ask for y equals 3 and I get x equals 3. Or I get a point on the graph and that's it. They give me 0, 3. So be careful with horizontal and vertical lines. They're simple, but the easy ones are the ones that get you in the end. Everybody practices the hard stuff.
So if you do ask those points, just put y equals 3 or something.
If I ask you to, what's the equation of a line, right? I'll ask, what is the equation of the line through -4, -5, parallel to y-axis? What is the equation? Ooh, question mark. What is the equation of the line that goes through -4, -5, and is parallel to the x-axis?
Y.
What should you do?
Said y. It's y axis.
What would I do?
Well, if it's parallel to the y-axis, then it's going to be equal to the line.
I draw a picture. Anytime it deals with horizontal and vertical, I'm always drawing a picture, at least a generalized one, so I can see where the heck things are. I'm a very visual person. -4, -5 is in which quadrant?
The third.
1, 2, 3. Plot a point. If it's parallel to the y-axis, is it vertical or horizontal? It's vertical. What's the equation of this line that goes through -4, 5 and hits the x-axis?
Oh, it's yeah.
It's x equals -4. It hits the x-axis and it hits it at -4. So the best way to deal with horizontal and vertical, draw a picture. Guaranteed, without a doubt. It has to go through this point. It's got to be parallel to the y-axis. That means it runs vertically. When it hits the axis, you could pretty much say it hits the x-axis at -4. And there's your equation. If it was parallel to the x-axis, the equation of the line would be?
Wait, say that again.
If it's
that
parallel
same
to the
point?
x-axis.
Y
Yeah,
equals
same
-5.
point. It's going this way.
Y equals -5.
It would be y equals -5. Because it hits the y-axis at -5. And the slope would be 0, and this one would be undefined.
Good.
Straight up and down, undefined. Can't even talk about it. All right, so that's slope. How exciting. While we're talking about slope, we're going to backtrack. Backtrack number 1. If we have a graph, the graph could do anything, but I'm going to make it do this. This is some function, let's call it f of x. This is going back to 1.3, I think. It's in 1.3. But it has more to do with slope than it does with functions itself, even though they're interrelated. Where'd that come from? Down the hall to the right. And let's say this is A, and this is B. All right, so this is a general function, and general coordinates on the x-intercept, or x-axis. The coordinate of this point here is A, f of A. The coordinate of this point here is B, f of B. And I'm going to draw, or try to, draw a line through these 2 points. Ah, missed it. Let's make that point really big so it hits the line. This line has a special name. Does anybody know the name of a line that hits a curve more than once? Think circles. If you have a circle,
A diameter.
this is the center, this is a
That's a
radius,
radius.
this is a,
Diameter.
this is a
A
chord. Okay. Let me change colors.
I can't remember the last one.
This is called a line on the outside of the circle that hits the circle exactly once. Tangent. So this one's tangent. In calculus, that becomes a very important word. The other one is a line on the outside that hits the curve more than once.
Arc.
It's not called well, it cuts off an arc, but the line itself has a special name. It begins with an S.
Sine.
No.
Segment.
No, not segment. No? Oh, maybe you didn't learn it. Secant.
Yeah.
It's a weird word.
Secant. So this line here, this green line, is called a secant of the curve f of x. Now, if I could create a secant where it only touched the curve only once, we can consider it a tangent. Tangents are really, really important. All right, so we have the secant, and what I want to find is the slope of that secant.
You missed a lot.
Sorry.
I don't get it.
What? You don't get it.
No, it's about what she meant.
Now, let's change our idea of what this graph is talking about. If the x-axis is time and the y-axis is distance, then the slope of this line becomes your change in distance with respect to change in better known as like miles per hour, a rate. So we can also consider this slope a rate, and it's called also, besides the slope of the secant, average rate of change.
Like, is that another way of saying like velocity in better sense?
Velocity is a little bit different than speed. Speed is an average, and if you drive from here to the ocean and it takes you 2 hours, are you driving the same velocity the entire time?
Probably not.
Probably not. Your velocity is going up and down, but you can average your distance that you covered over the amount of time and come up with an average speed.
About,
That's what this is doing.
about
Yeah, be classic. So, if the question is asking for this, you change it into simple one-word thing. If it says average rate of change of a function, you say slope. To find slope, you need 2 points. So you either A, memorize the formula that's in the book, and I'm going to come up with it in a second, or B, you keep it simple, and it's the slope between 2 points on a function. And then life is a little easier. So let's say I want to find the slope of the secant line. Well, that would be change in y over change in x. What's the change in y between these 2 points?
f of b minus
F of b minus f of a over the change in x,
b minus
b minus a. This is the formula. If you want to memorize the formula for the average rate of change of a function, be my guest. But it's really not worth your time. If you just see that word average rate of change and change it right into slope, your life will become a little easier. For instance, if f of x is equal to x cubed minus x squared, 3x squared, and I want to find the average rate of change on -1 to 2. How do I convert this into coordinates? Well, coordinates always come with an x and a y. What did I give you?
You just
you
Give it to
gave
us.
me.
Did I give you x and y?
No, because that's something.
What is this called?
I thought.
What's this called? We were doing it earlier. You know, negative infinity to 3, 3.
Domain.
Well, it's a domain, sure.
Domain.
This is definitely a domain. It's an interval of the domain. The domain of this function is all real numbers, so we're just looking at a very small portion of it. So, is -1 an x and 2 a y? Heck no. Because this is a domain, they both must be x's. So when you see this notation, the first thing you should do is separate it into x equals -1 and x equals 2. Great. So I gave myself 2 x values. I need points. So how do I generate points out of this?
Plug it in the equation.
You plug it into the functions. So the first thing you do is this becomes f evaluated at -1, which is equal to, well, something cubed minus 3 times something squared.
It's gonna be what you showed us earlier.
No, it has nothing to do with that. Plug it in, -1. This one becomes
No, negative. It stays negative.
positive -1. So that's -1. This one becomes
Positive 3.
-3. -1 squared has to happen first. -1 squared is positive. Positive 1 times -3 is -3. So f of -1 is equal to -4. This is a coordinate. This is the coordinate -1, -4. So there's one of my points. How do I get to my next point? Plug in the other number. F of 2. So if I do f of 2, starts off the same, something cubed minus 3 times something squared. What goes in the parentheses? 2. 2 cubed is? 8. Minus 12. Be -3 times 4. And then 8 minus 12 is? -4. So this coordinate is 2, -4. I didn't plan on this. Trust me, I did not plan
Yeah, I
on
was
this.
gonna say.
If I find the slope between those 2 points, change in y over change in x, this is equal to -4 minus -4 over -1 minus 2. Either way, I blow a whistle at this, the answer is 0. So this thing has an average rate of change of 0. What does that mean? Well, when I look at this graph, all I'm looking at is a horizontal line. Does that mean the graph is horizontal?
No.
No. It just means you ended up back where you started. Displacement if you're into physics. I didn't plan on that. I was hoping it would come up with a number other than 0. 0 is a perfectly fine answer, by the way. I know some people, they get to 0, they're like, oh, I must have done something wrong. There's nothing wrong with 0. It's an actual number. It works. So that's average rate of change. Real simple. The other thing related to slope, and basically related to average rate of change, but it comes up with the other word, the tangent, rather than the secant. We have to change our picture just a little bit. I'm recording, right? Yeah. Change the picture. Still an XY axis. Still some strange curve going through here. Let's call this one g of x, just for fun. And we're still going to be talking about 2 points, but I want to name them different. Let's call this one x. Where can x be? Where can that x be?
B, G of X.
Anywhere. It can be anywhere. It could be to the left, it could be to the right, because x is a variable. It can change places. Where a and b are considered constants, they're fixed. We consider x to be a floatable variable. All right, so I'm going to choose x just to be a random start point. Instead of choosing like y over here or b or whatever, I'm going to push a certain distance away, h. Now h is another weird number. It could be positive, so I push it to the right, or it could be negative and I can push it to the left. There's no indication which way I'm going with it, but generally they push it to the right. So if I push it to the right h units, what does that one become?
X plus H.
X plus h.
Okay.
Great. So my 2 x values I'm going to be looking at are x and x plus h. Okay. Go up to the curve, generate points. This one is x comma
Or G of X.
g of x. This one here then would be
X plus H.
very long, ugly expression. All right. And again, we're going to have a secant line going through them. Let's see if I can draw it decently. It's not too bad. Now, the difference between this and the average rate of change is quite this. I didn't choose h to be any number at all. H can be anything, positive, negative, and it can be as small as I want. And what I'm going to do with that h is I'm going to make it smaller and smaller. And as I make it smaller and smaller, my point is going to travel along the curve until it gets really, really close to that green one there. And then I'm going to have what's called a tangent.
So why'd you move it at all?
Well, I'm going to let h go to something called 0. There's a problem with 0. What's the big problem with 0?
It's nothing.
You can't divide by it.
No.
But slope, if I make h equal to 0, we're going to be dividing by 0. You'll see in a second. So let's find the slope between these 2 green points, x plus h, g of x plus h, and x, g of x. So the slope, change in y over change in x, is equal to g of x plus h minus
G of X.
minus g of x, all over
X plus H.
x plus h minus x. The nice thing about this expression,
That turns into H.
yeah, the 2 x's are going to cancel on the bottom, which is perfect. So this becomes g of x plus h minus g of x, all divided by h. This is called the difference quotient. One of the main topics of calculus. Good old difference quotient. Now notice, h is in the bottom here. So if I make h go really, really close to 0, we're eventually going to be dividing by Well, 0, and I don't want to do that. So there's a neat little thing that happens when we go through the math of this. For instance, I don't think I want to deal with the one I had here. Let's look at f of x, for example. F of x equals 3x squared minus 7. 3x squared minus 7. And I want to find the difference quotient. Find the difference quotient.
Do we just use that?
It just dumps right into this formula. Now, the nice thing about this formula is g of x is that function. In this case, f of x. It really doesn't matter what you call it, George or Frank. H is always h. So the only thing you really have to find is g of x plus h. In this case, f of x plus h. So if I'm going to look for f of x plus h, that would be my first step. I love when people do this. They'll write f of x plus h over here. They'll write 3x squared minus 7 plus h. They'll just add on an h to the end of it. It doesn't make any sense. I highly suggest when you're dealing with functions, give yourself some room to work with. What goes in those parentheses? X plus h. Because I'm looking for f of x plus h. It's the only piece of the formula that I do not know. Okay, expand. What's x plus h all squared?
X squared plus hx.
2xh h squared.
My lord. X squared plus 2hx plus h squared minus 7. If you don't know where that's coming from, it's x plus h times x plus h, and you're foiling it all out. Distribute the 3, and you're going to get 3x squared plus 6hx plus 3h squared minus 7. Notice I didn't write f of x plus h in front of it. I just wrote the answer here. Well, this is g of x plus h, if you want to think of it that way. It goes into this position. Minus something. What's the something? The original function, which is 3x squared minus 7. All divided by h. So all I've done is substitution. I found my f of x plus h, that goes in the first spot. I subtracted away my entire original function, that goes in the second spot. It has to go inside parentheses. And then you just divide everything by h. It's pretty simple. It is, isn't it? What happens to the 3x squares?
They're going to go away.
They're going to go away. That one's positive, this one's going to become negative. This is a negative 7, but this is going to become... If they're polynomials, the original polynomial should always cancel the entire thing. The original polynomial. Go for it.
It's because there's an h on the bottom and there's a 6h.
We're getting to that. We're getting to that. Slow down. Jeez. In the top is 6hx plus 3h squared, all divided by h. They all have one common factor of h. So basically you can remove one h from each of them. So that leaves 6x
plus 3h.
plus 3h. And this is considered the difference quotient of f of x. Now what's nice about this expression, if I let h equal 0, is it okay here? Yeah.
Sure.
And that's what's nice about this. So technically I'm dividing by 0 and coming up with an answer. Yeah, that's calculus for you. Crazy stuff. Alright, so let's play with our algebra. Polynomials always work this way. There's other functions that are not polynomial of nature that you still have to be able to work with. For instance, what time have I got? Plenty of time. Let's look at f of x is equal to 2 over x minus 3. Rational function. Simplistic one, but still a rational function. What can x not equal here? Definitely cannot equal 3 because that would cause a 0 at the bottom. So that's not part of the domain. You can't let x equal 3. We'll talk about that later also. So if I want to do the difference quotient, find the difference quotient of this function, the first step is always the same. We still want to find f of something, which is equal to 2 over something minus 3. What goes into something?
X plus
The x plus h. Would it be a mistake if you put x minus h?
Yes.
Actually, no, because
you
h
said
can be
that you
positive
could-
or
yeah, yeah,
negative.
you could go to the left.
It'll give you the same basic answer, eventually. It wouldn't look pretty, but eventually you'd get there. So, here's my f of x plus h. There's not much I can do to the bottom. There's no expansion, I can get rid of the parentheses, but not much else is going on. So this becomes 2 over x plus h minus 3 minus
2
2
over X
minus
the original function over the whole thing,
3.
h. What is this thing, this ugly, horrible thing called?
Of the fraction.
It's a fraction.
Double fraction.
Double fraction, complex fraction?
Yeah, that's it.
Complex fraction. How do you simplify complex fractions? Easily.
Do the x times
There's no cross multiplication, there's no equal sign there.
darn.
Supposed to
Oh,
multiply
yeah.
Find the common denominator and multiply everybody by it. Every term. So, you take the common denominator and you multiply him and the h by it. So what's the common denominator here? Well, h only has 1 in the bottom, so we don't worry about him. This one has x plus h minus 3. That's part of it.
X minus
And x minus 3. So I have to take every single term and multiply it by x minus 3 and x plus h minus 3. Take this thing, multiply it by x minus 3 and x plus h minus 3. If you do enough of these, there are shortcuts that you can play to get to the answer. You don't have to write all this out, but I like showing it the first time. X minus 3 and x plus h minus 3. So each one of these terms is getting multiplied by that ugly mess. No, it isn't. It isn't. But I like writing it out every time because I can do this now. This x plus h minus 3 is going to cross out with this x plus h minus 3. Because they're, one over the other, and they become 1. So what's left is 2 times x minus 3. I'm going to leave it alone. 2 times x minus 3. Minus. Over here I can cancel an x minus 3 out. What's left?
X plus h minus 3.
Don't forget poor old 2 here. And x plus h minus 3. All over, anything canceling out in the bottom? No, just write it down. This is h, x minus 3, x plus h minus 3. Can't mark anything up. Why?
Because that's not, because of subtraction.
You can only cross out through pure multiplication and pure division. You can't touch it when it's pluses and minuses are lying around. The best we can do is expand the top out. If you expand the top out, this becomes, let's come up here, 2x minus 6 minus 2x, well, minus 2h plus 6, all over h, x minus 3, x plus h minus 3. What happens to the top?
The 2 x's cancel, and so
The 2 x's are going to cancel out,
and then the 6.
and the 6's are going to cancel out. Anything else while we're there?
No, that's it.
I can cancel out an h too, right?
Or just be 1 month.
So it'll be negative 2 on the top, over x minus 3, x plus h minus 3. And that would be the difference quotient of f of x. And again, we can let h equal, I forgot parentheses, 0. We can let h equal 0. Or if you want to talk calculus language, get really close to 0. What was that? We're at the zoo and we're in the wild bird area.
Why did you erase that? Oh wait, you didn't erase it. Okay,
I just erased this half.
I was how you erase that.
No. I always leave up what I put up there last. Another possibility. You're going to hate this one. Well, I think that one's worse, personally.
Yeah.
What if I have g of x is equal to the square root of 3 minus x? Let's keep it somewhat simple. Or here, can x equal 4?
4.
Can x equal 4?
No,
No.
because then it would be,
Imaginary.
Yeah.
Imaginary. Not a real number. So 4 I would not consider part of the domain here.
Can't be less than 4,
Fine.
or more than 4.
The difference quotient. Same formula, different flavor. I can ask any of these 3 flavors. Polynomial, of course, will not be on the test because it's way too boring and easy. So that leaves you with a rational function and, well, a square root function. Same first step. I need to find g of something. So you get that. It's going to be g of x plus h. That doesn't change. The nice thing about radicals and the rational function is you don't have to do a lot of algebra at the beginning. Most of your algebra is at the end. Polynomials, all your algebra is in the beginning and very little of it is at the end. It's just
Would it
simplified.
always be x plus h?
Yeah.
If it's different quotient, always x plus h. It's the first thing you look for. And then you plug it into the formula, g of x plus h minus g of x, all divided by h. And what goes in that first parentheses?
Yeah.
That mess. So this is the square root of 3 minus x minus h. And then this one becomes the square root of 3 minus x. I really, really want that h in the bottom gone. But what can I do?
You gotta get rid of that.
You can square it.
Square root.
You can't square it. There's a minus sign there. If you square it, you'll end up with one gone and the other one gone, but then you end up with a 2 of them in the middle. Because of FOIL, first out here to last. What else could I do? By?
Do you, the 3 minus, all those parentheses?
Let me ask you this question. If you have 2 over 1 minus the square root of 3, is that legal? No. How do you simplify it?
You would do 1 plus the square root of 3.
Also known as the conjugate.
That
Conjugate.
1 plus.
We're going to multiply by
Conjugate.
of this ugliness.
Yeah.
Okay. So we're going to take the entire top and multiply by the square root of 3 minus x minus h plus the square root of 3 minus x. And then the same thing in the bottom. Oops. Didn't mean that. Plus the square root of 3 minus x. The bottom's not that important. It's the top that's really important. Whew. Conjugate time. So, when I multiply this radical times itself, what happens? The square root goes away and you're left with 3 minus x minus h. When I multiply the first radical times the second one, and the second one times the first one, outer, inner, I'm going to get 2 of them, but the radical has to stay, unfortunately. But the problem with that is, one of them is going to be, and the other one's going to be, and they go away. So we're going to get plus 0. And then we get the last one times the last one. And you got to be really careful. It's going to be negative, and the radical goes away. But you have to make sure it stays in parentheses. That way that negative affects the first one and the second one. All over h times the square root of 3 minus x minus h plus the square root of 3 minus x.
Wait, how'd you get 0?
The 0 is the outer and inner. When you multiply by the conjugate, you're going to get a positive one and a negative one. So the inner and outer are going to cancel automatically. All right, what's cool on the top is the 3 goes away. Right?
Yeah.
3 goes away,
Then the x's.
and the x's go
Then
away.
you're left with h.
So you're left with negative h over positive h,
Which goes away.
which becomes,
Oh, negative 1.
so you get negative 1 over the square root of 3 minus x minus h plus the square root of 3 minus x.
But now you can. And then that's
H can go to 0. Because if you put 0 here, these just become exactly the same. Which is kind of cool. So that's the difference quotient. Those are the three possibilities.
My brain's still fried.
Your brain fried?
Yeah.
Fried brain.